define operation between vectors. Addition and multiplication by a scalar, which is simply by a number, by a real number. The value taken in each, let's say, element of the n-pole define your vector is simply called coordinate. So whether you are used or not, a vector is simply a point in Rn. Sometimes it's useful graphically to represent it as a segment joining the region. The region is the vector having all coordinates 0. This is the origin 0, 0. And sometimes even somehow in an precise way, but graphically suggestive, they're denoted by an arrow. And sometimes you will have received that information about that the vector is defined by an arrow having a given direction and a verse. And why? And it's why you need the arrow. But really, we are talking about coordinates. If you have the coordinates, you don't need, unless you find it useful for better understanding, to draw any arrow. This is a vector. Still, this notation is useful for what? It's useful to graphically perform operation with vector. What are the basic operation with vectors? They are the sum and the multiplication, or even shorter, product with a scalar. This is called scalar because it somehow modifies the scale of the vector. It either expands the vector or it reduces its dimension when it's positive. So you can define the opposite of a vector is the opposite, not the inverse. Simply for sake of being clear and preventing ambiguity. So the opposite of a vector is a vector having as coordinate minus its coordinate of the original vector. And the sum between two vectors is to be performed coordinate by coordinate. So the sum of two vectors is a vector having as coordinates the sum of the coordinates of the two vectors. The multiplication of a vector by a real number, by a scalar, is a vector having its coordinate, having, let's say, for its coordinate, the product of the scalar of the number with the corresponding coordinate of the original vector. And the origin is also called zero vector. So let's try to provide some graphical understanding of those operations. So here should be easier than drawing graphs of the function. So here we have a vector. Its coordinates are, say, x1 and x2. So in order 336 to find the opposite, you have to find 369. You have to find the vector having as coordinates, this is minus x1, and this is minus x2, minus the coordinate. Here, this is, say, A, and this is minus A equal x1, x2. Simple. So if you want to mimic the sum of two vectors, let's make it in the first quadrant only. What do we have to do? So here we have vector one vector, say